Imagine dropping a robot into an unfamiliar airport terminal with just one instruction: find the lounge. No map, no GPS coordinates, just signs, the same visual cues humans rely on every day. Can the robot read a directional sign, understand what it means, and figure out which hallway to take? Building on that challenge, the researchers identify a fundamental gap in robot navigation. Sign grounding, the process of interpreting multimodal signage and mapping it to navigational actions, remains highly non-trivial because of variability in sign formats and the need for compositional reasoning about abstract instructions. The authors introduce SignScene to bridge this gap through a novel sign-centric approach. Connecting these pieces together, SignScene operates through 3 specialized modules. The system parses signs with in-context learning, constructs abstract top-down maps aligned to each sign's perspective, and uses vision-language model reasoning to ground instructions to specific paths in the robot's local workspace. This diagram reveals the full processing pipeline. Starting from raw camera observations and robot poses, the system aligns to signs, parses their content, selects goal-relevant candidates, and constructs the abstract map representation that enables spatial queries. Each component feeds into the next, creating an end-to-end navigation capability. Digging deeper into the representation itself, the abstract top-view map proves critical to performance. The researchers discovered that aligning the map to the sign's canonical frame and keeping the visualization minimalist, without extraneous markers, allows vision language models to reason more effectively about spatial relationships, mirroring how humans process directional signage. Let's examine how well this approach actually works in practice. The empirical results are striking. Across diverse real-world environments, spanning hospitals to shopping malls to university campuses, SignScene achieved 101 successful groundings out of 114 attempts. This represents a dramatic improvement over previous methods, with the closest baseline achieving only 26% success, a gap of more than 60 percentage points. Here we see the system in action on a physical robot. Given only the goal terrace, the robot autonomously explores multiple signs, identifies the relevant directional information, constructs its abstract spatial map, and successfully grounds the instruction to take the stairs, all without any pre-built map of the environment. Of course, challenges remain. The researchers candidly identify 3 main failure modes: incomplete detection of explicit structures like escalators, difficulty parsing multi-step or compositional instructions, and occasional reasoning errors by the vision language models themselves. These point toward clear opportunities for advancement as foundation models continue improving. SignScene fundamentally reimagines robot navigation by teaching machines to leverage the same environmental conventions humans use every day, transforming signs from passive wayfinding aids into active navigational intelligence. Visit emergentmind.com to explore the full paper and discover how this work opens new pathways for deploying robots in complex, unmapped human spaces.